Hello and welcome to this R tutorial. Today we're going to implement the naive Bayes algorithm on R. So let's start right now. Let's first set the folder as working directory. So I'm going to part 3 classification, and that's the folder. So make sure you have the social network add CSV file, and if that's the case, click on this more button here to set this folder as working directory. And now let's start implementing naive Bayes on R. So we're going to take our classification template, we're going to take everything from here to here, and then paste right here. And now we just need to change a few things. So first, let's change the titles, our usual, so that we don't forget. So here we are with the naive Bayes classifier. Same for the training set. So that is plotting the title in our graphs. And now what we only need to do is to create our naive Bayes classifier. So let's do this. I'm going to remove this. And now what are we going to do? Well, it's actually funny because we're going to use a library that we already used before, but for a different classifier. It's the E1071 library. So there is no surprise why this library is very popular, one of the most popular ones, because it contains a lot of tools for SVM and tools for naive Bayes. So here again, we'll use this library. So for those of you who didn't follow the SVM tutorials on R, and for those of you who are starting R for the first time, maybe you don't have the E1071 packages in your packages list. So if that's the case, you just need to type the command here install.packages, and then in quotes here in the parentheses, you just add the name of the library, which is E1071. And then you just need to select this and execute to install the package. I won't do it here because I already have mine installed, but I promise you it will work properly. So I'm just going to put that in comment. Here we go. And now let's just also import the library that is to select it in the packages list, because here it's selected, but it might not always be the case. And if you want to automate your machine learning scripts, it's better to always have this script line here that selects automatically your packages. So library E1071, and now we are ready to start creating our naive Bayes classifier. Okay, so let's do this. As usual, we will create a variable classifier, and then we will use the naive Bayes function of the E1071 library. The E1071 library contains a lot of functions, and one of them is to create a naive Bayes classifier. So careful with the capitals. So it's not capital N, but capital B. All right, but then, R is helping you with the terms, so you would have this naive Bayes popping up here, so you just have to press enter. And now let's input the parameters. So the parameters, what are they? Let's look at them. We press F1 here to have a look. And here they are. So we will actually need to input only the 2 first arguments. We won't need to input the formula like for the other one. It will work perfectly well with only the first 2 ones. So you'll see, let's input X here, which is, by the way, the training set. So the training set, but we need to remove the last column of our training set because X is actually the matrix of features. You see, it's written here a numeric matrix or a data frame, and by that they mean the matrix of features, that is the matrix of the independent variables. So here, since the training set contains both the independent variables and the dependent variable, we need to exclude the dependent variable. So to do this, we're going to add brackets here and remove the last column by inputting here a minus, and then the index of the last column, which is, well, we can see here it's -3. So it's -3. All right, so perfect. Then comma, and then next argument. So do you guess what the next argument is? Well, of course, to train a classifier, we need the independent variables and the response. And the response is the dependent variable. So of course, y is going to be the dependent variable. So y equals, and to take it, we are going to take it this way. We're going to input training set $purchased. So I'm choosing to write it this way because we can clearly see that we are taking the dependent variable purchased. All right, and that's all. You will see that it will work perfectly well. So I'll show you right now let's select the, oh, sorry, so before we have to select what's above, which is all the pre-processing steps. So Command and Control plus Enter to execute. All right, pre-processing, well done. We're good to go. And now we can create our classifier. So yes, let's do this. If your E1071 package is not selected, you need to select that as well. So Command and Control plus Enter to execute. And here is our classifier. Awesome. So as you can see, it works perfectly well. The classifier is well created using only those two informations. And when you think about it, well, this is all we need to train a classifier, because we need the information of the independent variables and the information of the dependent variable so that it can learn the correlations between the independent variables and the dependent variable. All right, so that makes sense. And now we can create our vector of prediction ypred using the predict function on our classifier and on our new data, which is the test set. So here we go. Ypred is created. Let's have a quick look. Ypred. So for the first time, we're obtaining something here. Remember before, when we entered ypred in the console, we had all the predictions listed in the console, but here we have this factor 0 here. So that means that ypred is a vector of factors, but with no factor. So it's basically an empty vector. And that is because the naive Bayes function of the E1071 library didn't recognize our dependent variable vector purchased as a categorical variable with 0 and 1 factors. So far, the libraries and functions we've been using recognized the dependent variable as factors, so we didn't have any issues with our predictions, and we didn't have to encode the dependent variable purchased as factors. But here with naive Bayes, it's not the case. It doesn't recognize the dependent variable purchased as factors, so we need to encode it as factors. Because as you can see, if we try to compute the confusion matrix below, we will get this following error message. All arguments must have the same length. Well, yes, indeed, we have a problem because the two arguments here are test set 3, that is the third column purchased of the test set, and then ypred. So since test set 3 has length 100 and ypred has length 0 because it's an empty vector with no factors, then obviously we cannot compute any confusion matrix. So what we need to do is to jump back up to the preprocessing first step to encode our dependent variable purchased as factors. Then the naive Bayes function will recognize the dependent variable as factors and will perfectly be able to create a classifier that will allow the predict function to return the expected vector of predictions ypred. So it's great that you see this error because this is a classic error in machine learning and R, and that way from now on you won't make this error in the future. Or if you make it, you'll know how to fix it. So let's do it right now. Let's add a new code section here and let's call it encoding the target feature as factor. All right, and now let's factorize our column purchased. Okay, let's do this. So we will take it from start. That means that we will take the purchased dependent variable column of the dataset, and then we will recompute all of these to set this purchased column everywhere for all our sets. That is a training set and the test set. Okay, so we're going to take our last column from our dataset. So we're going to type dataset $purchased, right, equals factor, and in parentheses dataset, and then again we're taking the purchased column that is the dependent variable column of our dataset. So again we're taking the $sign here and purchased to take this column, and then here we will just specify the levels. So our levels are C, 0 and 1. All right, and that's it. That's how you encode your dependent variable column purchased into factors. And that's actually what we saw in part 1 data preprocessing when I explained how to encode a categorical variable and set it as factors. Well, here we have to do it. And actually, we are going to leave that in the template. We're going to leave this encoding the target feature as factor, because even if we encode the dependent variable column for our other classifiers like logistic regression, SVM, and the other classifiers, then it will even be better to have this purchase column encoded as factors so that we can know for sure that R recognizes it as a factor. Okay, for some classifiers we don't need to specify it, but let's include this anyway so that we never get any error. Alright, so we're going to start from scratch now. So to do this, we can clear everything. So that's what we're going to do. Clear everything here. So we're clearing the data, clearing the script here. So I'm pressing Control L to clear, and that's it. And now let's do the whole thing, and you're going to see that we won't get the error. So let's select this. Okay, so that's all the data preprocessing steps with now the encoding included. So execute. All right. Now we're going to fit the naive Bayes model to the training set. Execute. All good. Now we're going to create our vector of predictions, ypred. Okay, you're going to see that if I type ypred here, we will now have the predictions. So we can compare it to yset, which is the third column of the test set. Okay, so we can compare them, but let's not do this. Let's just get to the point where I want to show you that now a confusion matrix is going to be created without any error. So let's select this, execute, and now, as you can see, the confusion matrix is created without any problem. So, and now we can have a look to see the number of incorrect predictions, which is 7 plus 7 equals 14 incorrect predictions. Not bad out of the 100 observations of the test set. Okay, great. And now we're finally getting to the fun part, which is to visualize the results. So if you didn't follow the Python tutorials, a good exercise for you is to try to predict what's going to happen, predict what you're about to see. Based on the intuitions that Kirill explained to you, can you guess what prediction regions are going to be? And especially the prediction boundary. Can you guess what it's going to be? Is the naive Bayes classifier a linear classifier and then it will be a straight line? Or is the naive Bayes classifier a nonlinear classifier, but then is the prediction boundary going to be a smooth curve or a prediction boundary with a lot of irregularities like for K and N? That's a good exercise, to try to practice your intuition that you have just built. You need to practice it now. Okay, so you can pause on the video, and now I'll just select this to show you if your prediction is correct. So let's see, Command and Control plus Enter to execute. And there is our naive Bayes graphic results. Isn't it beautiful how this prediction boundary is a smooth curve classifying quite well the data sets? That is a data set of observations nonlinear separable. It's kind of like the kernel SVM curve, it's a beautiful smooth curve that manages to catch those green users that couldn't be caught by linear classifiers because we had the straight line and therefore it couldn't catch the green users here and put them in a green category. They were in the red category. But thanks to this curve, we can see that it's making less incorrect predictions, but still some, like those 1, 2, 3 here, regarding these users here, these older users with a low estimated salary that were incorrectly predicted by the linear classifiers. And then, however, it's still making some few mistakes here. We would have liked to have a lower curve here, like the curve starting from here, but that's what naive Bayes could do here, and that's already quite a good job. So now let's see what it does on the test set results. Here we have the test set results code. Let's execute it. And here's the test set. If the execution of this code is taking too much time, you can try to take a lower resolution, because right now you can see that we have a very high resolution with this by 0.01 step here. We cannot see the pixels here thanks to this resolution. If you take a 0.1 resolution, the script will execute much faster, but then you will see the pixel point. So it's as you want. So the test set results are actually not bad as well. It did a pretty good job classifying those green users here to the right green category, but still some incorrect predictions resist since those green points here stay in the red region. Alright, so that's the naive Bayes graphic results. I hope you enjoyed what you saw. We're gonna have other different surprises of other classifiers. You'll see that we will get very different kind of prediction boundaries when we look at the decision trees classifiers and the random forest classifiers. So I look forward to showing that to you, and until then, enjoy machine learning!